Hello everyone, I am Aarush, a student of grade 10 and a proud trainee at ASCampus. So today I'll be discussing about chapter number 1 of class 10 science, which is chemical reactions and equation. Chemistry is all about us, from the food we eat to the air we breathe. So let's step up into the chapter. But before stepping in, I would like you people to know what the actual heading of the chapter, chemical reaction and equation, mean. What is a chemical reaction? A chemical reaction is such a reaction which involves the use of chemicals in it and which occurs after a chemical change. So what is a chemical change? We have been learning from the previous classes what is a chemical change. A change which is irreversible in nature. So the chemical reaction, there is a formation of a new substance and as well as it is irreversible in nature. So next, what is chemical equations? Chemical equations are the equations which involves on the left hand side there are reactants and on the right hand side there are products. So let us dive into the beautiful world of chemistry. Chemical reaction, as I have already told you in the introduction, what is a chemical reaction? A reaction which takes place after the chemical change is known as chemical reaction. So how we would know that if the chemical reaction has occurred or not? So there are mainly 5 signs of a chemical reaction. Very first sign which is change in color. If the color has changed of the product, this means chemical reaction has occurred. Second one, evolution of a gas. If the gas is evolved out in the product, it means the chemical reaction has occurred. Third one, if the change in temperature has occurred, that is the temperature of the products and reactants do not match, it means the chemical reaction has occurred. Fourth one, change in state. If the state of the products is changed, that is chemical reaction is occurred. And the fifth one, we study formation of a precipitate. What is precipitate? Precipitate is a solid substance which is insoluble in nature. When the precipitate is formed, that is, meaning is the chemical reaction has occurred. So a equation can be written in 2 forms, word equation and chemical equation. Word equation involves the full name of the formulas of the chemicals into it. For example, hydrogen plus oxygen gives water, and in the chemical form we can write it as H2 plus O2 gives H2O. Here it is the example of reaction of methane and oxygen. When methane and oxygen will react, it will give carbon dioxide and water. Methane CH4, oxygen O2 gives carbon dioxide CO2 and water H2O. So chemical equation, I have already told you in introduction, which is chemical equation stands for the equation which involves at the left hand side product, reactants and the right hand side products. So what are the characteristics of chemical equations? The equation must represent the known facts and feasible chemical change. So we can't write that H2 plus O2 gives H3O positive whatever. So it should not be wrong. The equation must be a fact. Equation must contain the correct formula. We can't write formula of hydrogen as O2 because it is the formula of oxygen. So the formula should be very correct. The important conditions of the temperature, pressure and catalyst during the reaction must be written in the correct way. And the last one, the law of conservation of mass must be satisfied. We have studied in class 9 what do you mean by law of conservation of mass. Mass can neither be created and nor be destroyed. That is, the mass which was before the reaction and which is after the reaction will be very same. So let's talk about balanced and unbalanced chemical equation. What do you mean by balanced chemical equation? A chemical equation in which the stoichiometric coefficient. What do you mean by stoichiometric coefficient? Stoichiometric coefficient are the numbers which we use to balance the chemical equations which we use in front of the formulas to balance the chemical equation, in which the law of conservation of mass totally satisfy is known as balanced chemical equation. This is one of the example. Mg plus O2 gives MgO. So this was initially unbalanced. So unbalanced equation is also known as skeletal equation. So when we'll put stoichiometric coefficient 2 in front of magnesium, so here also we can put 2 because we have to balance. So here magnesium are 2, oxygen is 2. So this 2 is multiplied with magnesium as well and oxygen as well. So this is finally balanced now. So what is unbalanced chemical equation now? The equation which is not balanced. For example, let's see the previous example only. Mg plus O2 gives MgO. So this is not balanced because here are two atoms of oxygen, but here is only one. So this is known as skeletal chemical equation. This is known as skeletal equation, but when we will balance it, we'll write it as 2Mg plus O2 gives 2MgO. So this is finally balanced now. So let's move into the type of chemical reactions. There are mainly 5 types of a chemical reaction. The very first type is a combination reaction. This is a general form of a combination reaction. A plus B gives AB. So what is a combination reaction? It is a type of reaction in which various reactants are combined to form a single product. For example, the general form I have already told you, A plus B gives AB. The very common and famous example of combination reaction is this one. CaO plus H2O gives CaOH whole twice. This is slaked lime and its chemical name is calcium oxide. This is water, we already know, and this one is quicklime, sorry, and this one is slaked lime. This chemical formula and the chemical name of this is calcium hydroxide. Combination reactions are generally exothermic in nature. What do you mean by exothermic reactions? Exothermic reactions are the reactions which involves the formation of heat, in which heat is evolved out. So next type is decomposition reaction, in which a single reactant breaks into multiple products. And its general form is AB, when we can put anything here. For example, we can heat it, or we can give sunlight to it, H nu, or we can give electricity as well to it. So when AB will be break down into its products A plus B. This is a decomposition reaction. There are mainly 3 types of decomposition reaction, which is first one, thermal decomposition, in which the reactant decomposes with the presence of heat. Heat is denoted by a triangle sign. This is heat. And second one is electricity. We can put electricity to break the reactant. And third one is H nu, which is sunlight. Let's move to the next type of reaction, but before that we will study reactivity series. This is an important series. This is a series by which we can get to know which metal is highly reactive or which is less reactive. So next comes the displacement reaction. What is a displacement reaction? In which a more reactive metal displaces a less reactive metal from its solution is known as displacement reaction. For example of displacement reaction, if you will put iron and the solution of copper sulfate CuSO4, it will give iron sulfate plus copper. So this Fe displaces copper, as you can see here. This is an example of displacement reaction. Displacement reaction is also of 2 types, single displacement and double displacement. In double displacement, the mutual exchange of ion occurs, while in single displacement reaction, a more reactive metal displaces a less reactive metal. Let us come to the last reaction type, which is redox reaction. Redox reaction, what is it? A redox reaction is the one which involves oxidation and reduction, both processes in it. So what do you mean by them? Oxidation, in which there is an increase in oxidation state, or there is the gain of oxygen. Whether on the other hand, reduction, what is reduction? In which there is a loss of oxygen or there is decrease in the oxidation state. I'm saying the word oxidation state. What does it mean? It means the valency. It means the ability to gain or lose electron of an ion. So if a substance gain oxygen, it is oxidation, and if a substance lose oxygen, it is reduction. For example, this is a redox reaction. CuO plus H2 gives Cu plus H2O. So what is the valency of copper? It is +2. What is the valency of oxygen? It is -2. As hydrogen is a single, so we can put 0. We will put 0 here. Here copper is single, we will put 0 here. What is valency of hydrogen? It is +1. What is valency of oxygen? It is -2. So this copper was +2 before, now it is 0. So reduction is taking place. And this hydrogen was 0 before, now it is +1, oxidation is taking place. This was the example of redox reaction. So last comes the oxidizing and reducing agent. Oxidizing agent are those substances which makes available oxygen or removal of hydrogen, helps reaction to take place and facilitates the oxidation process, whereas reduction agents are those substances which makes available hydrogen or removes oxygen. On the other hand, these both oxidizing agent and reducing agent facilitates the redox reaction. These are the uses of oxidation and reduction in our daily life. So there are two main phenomena which we study, which are corrosion and vancidity. Corrosion is a very slow process of self-oxidation of a metal, in which a metal corrode by the reaction of moisture and air. We can study various examples in that, which is rusting of iron, tarnishing of silver, and copper turns green when it is exposed in air. The last comes vancidity. It is also a very slow process of self-atmospheric oxidation of food containing fats and oils, marked with unpleasant smell and taste. For example, butter turns rancid. If you will put butter for a lot of time, it will become rancid and smell will be coming, of course. So what are the ways to reduce these vancidity? Storing food in the airtight container, storing food low to temperature, storing food in dark containers to stop reaction by the help of sunlight as well. So use of antioxidants such as BHT, it stands for butylated hydroxycholine, and BHA, it stands for butylated hydroxyenziol. So finally, here a chapter ends. And at last, thank you. In conclusion, a chemical reaction are not just confined to laboratories, but they are happening in every single second all around us, from burning fuel to cooking food, from respiration in our bodies to the forming of rust. Every single change involves a chemical change in it, a chemical reaction in it. So I hope this presentation helped you a lot to understand the basics of this chapter, chemical reactions and equation. So if you like the video, please share, comment, and as well as subscribe the channel. Thank you.